Hey guys, welcome to the first episode in the computing course here at ECDE Foundation. In this episode, we'll go over a basic computing overview and go over an introduction to the computing course and learn about what's expected the next few weeks. So here's a full background of what we're going to be going over today. First off, we're going to be going over a quick introduction. We'll go over what the ECDE Foundation really is and what our main goal is. We'll also get into course info and go over the basic goals, the course schedule, and just other basic info that's going to be needed to complete this course. Next, we'll go over what computation really is and just grasp the key definition and concepts. And lastly, we'll get into the concept of abstraction and how to apply it to computer science. So now let's get started with the introduction. Hey guys, my name is Pranav, and I'm representing the ECDE Foundation. And here at the ECDE Foundation, our goal is to provide every student with a fair and equal education. And this means that we do not care about your race, your religion, your cultural heritage, or more. All we care about is that you're human. And if you're human, we believe that you deserve a fair and equal education. As I was doing some research on my off time, I came upon this quote, and I feel that this quote deeply resembles or resonates with what this course is going to cover the next few weeks and episodes. And it's how it goes. In their capacity as a tool, computers will be but a ripple on the surface of our culture. In their capacity as intellectual challenge, they are without precedent in the history of mankind. And this was said by Edgar Dijkstra at the 1972 Turing Award lecture. And don't feel tense or stressed if you do not fully understand this quote right now, but just keep this in mind because as we progress further and further in this course, this quote will appear once again and it'll just deeply resemble and correlate with what we're going to be going over. So why are you here? There are many reasons why you could be here, but one of them could be just out of pure curiosity. Maybe you want to find out about the computing tech and its many effects on society because as we've seen in the last decade or so, technology has deeply grasped our society, and many of our everyday items or household activities and just actions revolve greatly around technology. You could also be here for just professional development. Maybe you want to develop computing skills that can make you more successful at work. Now, just a quick reminder that computing skills are not just needed or required in the computer science field because they can be useful in just any workspace pretty much. You know, they can be useful in the medical workspace or even just in the arts in general. And lastly, you could be here for just intellectual growth. Computing changes the way how we think about problems. And you can learn to think like a computer scientist and just tackle problems the way computer scientists would. So now let's get started on computation. But before we can learn about computation, we need to know exactly what computer science is. And computer science is the study of what can be computed and how exactly to compute it. Computation is the performance of a sequence of simple, well-defined steps that leads to the solution of a problem. And computer is a device that runs these computer science and computation, performs steps, and remembers the results of those steps. Now, you may be looking at computation and thinking of it that it resembles the definition of problem solving. And yes, it does, because computation is pretty much another way of problem solving. And if you look at the definition of computer, you may realize that it's really basic compared to the devices that stay in your household, such as your MacBook and Windows. And yes, the guidelines of a computer are basic. And the reason why you may feel as if your computers in your house are complicated is because they are more complex. They contain these guidelines of a computer and many more features and parts, which make them so as complicated as they are today. So what kind of discipline is computer science? Now, computer science falls under three main disciplines. And the first one is science, as it focuses on abstract, artificial things in a virtual world. The second one is engineering, as it builds upon complex things by using techniques to manage complexity. Now, obviously, it doesn't involve any physical building, as it's mainly just virtual building. Lastly, It falls onto liberal arts as it has strong connections to traditional liberal arts of grammar, rhetoric, logic, arithmetic, geometry, and music. So here are some high-level goals of this course. In the end of this course, we want to help you guys think like a computer scientist, because when you think like one, you'll be able to identify problems that are amenable to computation and express computations to find a solution. You'll also be able to understand the power and limitations of computational tools and techniques. And lastly, you'll ask new questions that are not thought of or dare to ask because of scale and easily addressed computationally. Here are 3 skills that are to be gained by the end of this course, and that includes systematic problem solving, applying abstractions as needed. Now, we'll get onto abstractions later in this episode itself, so don't stress about too much about it. You'll also be able to read, write, and debug small, medium-sized problems using the language Python. Now, there are many programming languages out there that we could use, such as HTML or JavaScript, but I feel that Python is the best one to use because it's the most user-friendly and easy to grasp among beginners or people with just no computing background in general. We'll also develop a familiarity with computational concepts underlying pervasive technologies and a familiarity for computational vocabulary that you could see later in your professional workspace or just in a professional atmosphere. Don't worry too much about what debugging means. We'll get onto that later in the course, later in the course. So here's the basic course information as of right now. We have planned 1 video every 3 weeks, and we expect 24 videos overall from start to finish, but this information could change, so treat it as sensitive. But yeah, as of right now, this is the basic information that we're going off of. So as stated before, a computer does 2 main things. Number 1, it performs instructions, and number 2, it remembers your results. Historically, computation speed was limited by the human brain and the ability to record results by the human hand, but modern computers relieve us of those constraints, and this new era of technologies basically helped us get past this limitation, just expand and keep on creating more complicated and more efficient technology, including computers. Now, to understand how computers works, we need to think of the very basics, such as the hierarchy that composes sentences in the English alphabet, such that first off, you have the letters, which is A, B, C, D, E, F, G, and so on in the alphabet. And these letters combine to form words, such as ball, basketball, basket, etc. And then these words combine to form sentences, such as I played basketball with my friends. So that's the general hierarchy of how sentences in the English alphabet, or just in the English language, function. Now, if we go to the bottom where you see the 0 and 1, this is how the computer reads our code, and it's called the binary code. The computer doesn't actually read word to word how we program it. It actually converts that program to a string of zeros and ones, which it then interprets and carries out our function. And don't stress too much about binary code. We will be getting into it later in the course, so just keep it in mind and just have it in the back of your head as of right now. If you go up here, computers generally have 2 choices: on and off, yes and no, and true and false. And these are called Boolean aspects or Boolean values, as you can see in true and false. And the usage is yes or no. And how many options? In this case up here, there are 2 options for each of the values or scenarios. Now, as I stated before about binary values, this is an example of a binary value. The zeros mean no, and the 1 mean yes. There are 4 switches up here in the light switch, and each of these, so as you see in the table, these are all the possible combinations of outcomes for binary values. And each of these values encode whether the light switch will be on or yes, so whether there'll be a light or no. Now, obviously, don't stress about this too much. We'll get onto it later in the course. So now let's get into what a mechanical procedure really is. Computers execute mechanical procedures, or in other words, procedures that can be followed without any real thought. We need to give computers unambiguous instructions, such that when followed step by step, the execution will finish and yield a result. An algorithm is a mechanical procedure that is guaranteed to eventually finish. So as you can see here, when we're programming a language or just programming the computer, we need to be so descriptive and specific such that the computer does not need to think at all as to what to do, because once it receives instructions, it should be able to know right off the bat what to do, when to do, and how to do it. And an algorithm is just a specific instance of a mechanical procedure where there's always an end result, and it would always eventually finish. So here is just a procedure example. This is in regard to cooking, and it goes as combining the flour, sugar, yeast, and salt in mixing bowl. Start the mixer. Add water and 2 tablespoons of oil. Beat until the dough forms into a ball. If the dough is too sticky, add additional flour and beat. If the dough is too dry, add additional water and beat. Otherwise, stop and knead. Now, take the next 1 or 2 minutes, or basically however long you think this will take you. But based on our past few slides and the examples I gave you guys about mechanical procedures, think of this imaginative scenario. If I was a robot, how would you describe or navigate me on how to navigate in space? Now, there's no right or wrong answer for this scenario. Treat it as open-ended. I'll just let your creativity guide you, but take the next 1 to 2 minutes, pause the video, and just think of this answer. And once you're done, come back to this video and click resume. Okay, so I hope that was enough time to go over this assignment. Let's get straight on in. So here's another example of just one algorithm. So it goes as, take a card, write the number 1 and stand up, pair with a student who has a card in hand, sum the numbers on your cards. The shorter student cross out the number and card and write the new sum. The tall student sits, and the other goes back to step 3. So now let's get into primitives and abstraction. But before we read the problem on the screen, let's just get into abstraction in everyday life. Abstraction is essentially simplifying a set of tasks that you're given with and just creating a long list of tasks and just 2 tasks or less, or just pretty much a few number of tasks. Now, let's look at an example such as school. When you go to school every day on the weekdays, every day morning, the steps you could say is that, oh, I wake up, eat breakfast, I ride the bus, public transportation, carpool, whatever, walk, however you get to school. I go to my first period, I do my work, I go to passing period, second period, eat lunch, and etc. Right? There's a gazillion number of steps I could say as to what I do in school. Now, if we were to use abstraction, we can simplify these number of steps to just 1. I do my work at school, right? So this just simplifies all those steps you do in school into 1, where you say, I just do my work at school. Or it could say, oh, I do my daily activities at school, right? We're basically just simplifying it. Now, with this concept in mind, let's look at the instructions on the screen. Suppose I know how to draw lines along a given direction and turn a given number of degrees as I draw. Can you give me instructions to draw this house? Now, if we were not using abstraction, we would say, draw 1 line, 2 lines, 3 lines, 4 lines, 5 lines, 6 lines, and draw. So basically we're saying draw the 3 lines to form a triangle and 4 lines to form a square, right? That would be like, let's see, 1, 2, 3, 4, 5, 6, at least 6 steps, because there's 6 lines or 7 lines. So at least 7 steps, right? But if we use abstraction and we use the knowledge of triangles and squares, we could say draw 1 triangle and draw 1 square and specify where to locate it or position it. This greatly simplifies the code that or the instructions that we just put forward by drawing the lines individually, as we could group up the lines and make them into shapes. So as we use abstraction, we can think in terms of triangles and squares instead of lines. So now think of this scenario. We can even think in terms of houses, not just shapes. And what's the advantage of using abstraction like this? Now, don't overthink this. It's a fairly simple problem. Take like the next 30 seconds, just think of a quick response, and just pause this video right now, just think of a response or an answer, and just come back and click resume once you're ready to go on. Okay, I hope that was enough time. Basically, the simple response to this is that it would just make it simpler. You know, houses basically takes up has a number of steps, more steps in it than shapes. So you can just simplify the code further down. So now let's get into general purpose computing. We can design machines for specific computing tasks, such as getting the average of a set of numbers, or just adding up values or sums under general purpose computing. And number two, many earlier machines were fixed program computers. However, modern computers nowadays store sequences of information and execute them. And you may recognize this as the definition that we stated before about what a computer does or how it functions. And here are programs to describe mechanical procedures. What if we have millions of steps to specify for a computer? Well, we typically use high-level program languages to describe computations. Now, this includes HTML, JavaScript, Python, and etc. So now let's go over a quick review of what we learned today. First of all, we went over a quick introduction. We explained what the ECDE Foundation is and what our goal really is. We went over a quick course info, understanding computational vocabulary and understanding of Python and etc. And on top of that, we went over the course schedule, some goals, and etc. We went over computation, the performance, well, computation basically is performance of a sequence of simple, well-defined steps that lead to the solution of a problem. And then lastly, we went over abstraction, which is basically simplifying code with blocks and just combining action items into just one big action item. So here is the basic course direction that this course will cover in the next few weeks or months. First of all, step one, we'll be going over computation basics, including this episode and the next few episodes. After that, we'll transition to an introduction to Python, and then from there, go into advanced Python. And then lastly, we'll finish off with encryption and just basically other concepts. So next episode, we'll be going over a brief history of computing, including important people and inventions. So stay tuned to that. Now, you may be wondering why it's so important to go over the past. And you may have heard your history teacher say this, but it's important to look at the past so that we don't repeat their mistakes and we learn about what they learned upon, because it's important to always look at the past and just build upon it so that we progress further and further in society. So stay tuned for that. Okay, well, that wraps up today's lecture. Today, it was a brief computing overview and introduction. Make sure to like, subscribe, and comment down below, and stay updated for next episode on important people in the brief history of computing. If you are interested in other subjects such as business, AP Euro, and etc., make sure to check our channel down below. We have a vast number of videos covering a vast number of topics. So make sure to check that down below, and stay tuned for our next video, and I'll see you guys next time. Peace.